Welcome to this problem solving session, and this session is mainly for all the JEE NEET aspirants, 11th, 12th dropper students. I'm going to teach you the concepts, I'm going to help you with the concepts, how to apply them and how to improve your problem solving skills. That's the whole aim of today's session. And stay tuned till the end and make sure you have hit the like button and also hit the subscribe button so that you do not miss any of the classes. And also let me tell you, on this channel there is a beautiful playlist of all the chapters which I have taught, okay, of 11th as well as 12th. When you hit the playlist button, you will see it right over here. You can see JEE class 12th, JEE NEET both, and JEE NEET class 11th. You can see physics playlist. Watch all the chapters right from 1 to last chapter. Okay, beautiful playlist, guys, for all of you. You can see if you just open it up, right from basic maths to the last chapter out here. Okay, great. So let's begin with the class. Hello Arvelan 002. Wow, just like Bond has 007, you have 002. Hi Dazzle, hi Bharadwaj, hi Saki, hi Pooja, hi Shiv, hi Imran, hi Haris. Maybe some of you are watching my classes recorded. Some of you I'm seeing it for the first time on in this live class. Okay, welcome guys. So let's begin with the class and let me start with the revision. So pay attention, it's completely handwritten. You will get the notes in the PDF form in our Telegram channel, link in the description box. Okay, now everybody knows what is work, and if I talk about work, all right, immediately you will start thinking about this particular fact that if I have some body over here and let's say the body undergoes some kind of a displacement, okay, like this, and let us just say that there is some kind of a force acting on it. This is the angle between the force and the displacement. Then the work done on that body is F vector dot your displacement, which is also Fs cos theta. Now this work can be positive or negative depending on the angle theta. If you recollect, this value of cos is going to be positive if theta is basically acute. If theta is acute, that means the force and the displacement are like this. That means work is done on, or I would say the work is done by the force on that particular body. That's the meaning of positive work. That means you are doing some good thing. If I push you and you move, then my force and displacement are going to make an acute angle. In fact, it might take even 0. Then I am doing good thing. That's a positive work. This cos theta can also be negative. In that case, the angle between the force and the displacement is obviously obtuse. In that case, the work is done by the system, or I would say the work is done against the force. Against it. Like a Spider-Man, if you have seen the movie, trying to use his webs and trying to stop the train. The force by the Spider-Man on the train is this way, displacement of train is this way, force displacement opposite. The work is done against the force. That means, you know, you're sucking away the energy from the system. It's a bad thing. That's negative work. And 0 can happen in many situations. If it is basically 0, that means the force is perpendicular to the displacement, or maybe the work is 0 because either the force is 0 or the displacement is 0. All the possible cases are there in case there is no work done, right? Thank you, Hari's ideas. Thank you so much. Hi, Kalyan. Hello, auto rickshaw. Wow, we have auto rickshaw too. Very nice. Great. Now, let me ask you some simple questions so that you realize how much you know or you do not know. You will understand how deep your concepts are. Let me just ask you this simple example where, you know, there are two teams. Okay, this is a very, very interesting example, guys, where you have two teams. Let's say this side you have Pandu. Okay, this side you have Pandu, and there is a rope, and this side you have Champa. Who is there? Champa is there. What are they doing? They are playing tug of war. What are they doing? They are playing tug of war. Okay, beautiful question, guys. And let's say, whose team do you want to make win? Do you want to make Champa win or do you want to make Pandu win? I think we had done similar question in Newton's laws also. I think there Pandu won. Maybe this time Champa wins. So Champa is, let's say, the winner. Champa is, let's say, the winner, and Pandu loses the tug of war. Cool? Okay. Now, here is my question to you. If I ask you a simple question like, what is the work done? What is the work done by Pandu on that particular rope? Work done by Pandu on that particular rope. Will your answer be positive or negative or zero? Let's see. Okay. Abdullah saying Pandu, Nandini saying Champa. Uday is like, okay sir, anybody wins. I find this funny, no problem. Work done by Pandu on the rope, or basically, if you don't like on the rope, on Champa. Also I can say, work done by Pandu on Champa. One and the same thing. Rope is directly attached to Champa. Think about it. Champa is here. Champa is going like this with the rope. Pandu on the rope is applying the force this way. Pandu on the rope is applying the force this way, whereas the rope itself is displacing this particular way. Force by Pandu on the rope is this way, rope's displacement is that way. Clearly it is obtuse, hence the answer must be a negative value. Everybody with me on this? No, it is not zero, it is negative. Very good, Varun, Isaki, and 7 Pro. Like I told you, these questions are conceptual. You will understand how well you know your concepts. Now observe this. If I ask what is the work done by Champa on Pandu, what is the work done by Champa on Pandu, then what is your answer, guys? Is it going to be positive, is it going to be negative, or is it going to be zero? Think carefully. Okay, Champa on Pandu. Champa is going like this. Pandu is getting pulled. He is the loser. Remember, he's getting pulled like this. He's losing it. So Pandu's displacement is like this. On him, the force is also exactly the same way. On Pandu, force and Pandu's displacement are in the same direction. Obviously, if it is acute angle, the work done must be positive. Positive work. Exactly. Very good. Now comes the biggest question. Pandu is getting dragged. Pandu is getting, what is he getting? Dragged. He loses and he is getting dragged. Champa is winning and she is coolly walking backwards. Walking back. As simple as that. What is Champa doing? She is walking. She is very strong, powerful. She's just pulling Pandu back. That's it. She's winning. Pandu is like, oh my god, 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 he's getting dragged. Like that. So now the question is, won't there be some kind of a friction on Pandu and Champa? Yes or no? Won't there be some kind of friction on Pandu and Champa? Now here is the question. What is the work done by the friction on Pandu? That is the question. Is it going to be positive, or is it going to be negative, or is it going to be zero? Think carefully. What is the work done by the frictional force on the Pandu? Pandu is getting dragged. He's slipping and he's going like this. He's going like this. I think there will be some kind of a kinetic friction on it. There will be some kind of kinetic friction on the Pandu. In fact, Pandu is going like this. Friction will work against him. Friction will work against him. Isn't that right? Hello, Kushi. Hello, Uday. Welcome, Bacha. Isaki saying zero. Negative says Madhusudan. Interesting. Think carefully, guys. The friction will act this way because the sliding is happening. The relative motion is happening this way. Pandu is getting pulled this way. Friction will work against it. So the frictional force is this way, whereas Pandu's displacement is this way. As Pandu's feet get dragged, you will see the feet is moving forward. The friction also shifts this way, but it's acting this way. So hence, clearly, it must be negative. It is sucking away the energy. When his feet are rubbing against the ground, imagine his feet will be rubbing like this. It will be creating some heat. You just rub your hands. Just rub your hands. Do you feel some heat? Where is that heat coming from? Frictional work being done. It's sucking away the energy and it's creating it as heat loss. Excellent. Now, the most important question. The work done by friction on Champa? Believe me, I have asked this question to many teachers during interview, and I have hardly seen less than 5%, or not even 5%, less than 1%, I would say, teachers answering all these questions correctly. I'm not kidding. सुजीत, मैंने खाना नहीं खाया अभी तक, दोपहर का खाना खाओ गया, शाम का नहीं. I will have my dinner later on, बच्चा. Let's see how many of you can do this. Work done by friction on Champa. I'm telling you, less than 1% to 5% of teachers have answered these questions rightly. Okay, animator saying positive. Is it going to be positive or is it going to be negative? This is going to be a shocker to many of you. Negative, positive, negative, positive. Come on, guys. Come on. Let's see how many of you can get this. Very, very important question of today's session. Guess what the answer is? The answer is a big, big 0. You will be like shocked listening to this. You will be like, what nonsense. Are you saying there is no friction on Champa? Obviously not. No, I'm not saying there is no friction on Champa. In fact, when Champa is walking backwards, there is going to be friction, or else she will slip and she will fall down. Without friction, you cannot move, you cannot walk, you cannot run. Now you'll be like, sir, if there is friction, how is and there is displacement, Champa is moving back, how can the work be 0? Tell me that. This is where you should know the concepts. When you walk on the ground, many people think friction is bad. Sir, friction is evil, sir. If friction is not there, life will be so good. No, it's not like that. In fact, let me tell you, when you just walk on the ground, the work done by friction is still 0. You're just walking. I'm just walking. Let's say I'm walking here. The work done by friction is 0. If you go by this formula, which has been taught to you in school or in coaching, you will be like, yes, friction's work done is negative. But if you listen to this class, you will understand why it is 0. Observe now. When I say it is F dot S, guess what this S is? S is not displacement. Till now, you always used to think, many of you think that S is displacement. That's completely wrong. Or if it was taught that way, that is also wrong. S is not the displacement. Do you know what S is? S is the displacement of the force. That's very crucial. Not many people know that. Now, because of this, a lot of things change. How? Observe. Champa, she puts her foot. She lifts it again and puts it here. Again she lifts it, again she puts it here. She's walking backwards. She takes her leg, she puts her leg back, again lifts it, again puts it back. Lifts it, again puts it back. Tell me, when the leg is in contact, is it slipping? Is the leg slipping? Is the leg slipping? Yes or no? You will understand what is the meaning of this. Is the leg slipping? Champa, not Pandu, guys. Champa. She's just coolly walking backwards. She's just coolly walking backwards, guys. Is the leg slipping? Yes or no? No, right? That means, will the frictional force move? Friction will still act at the same point till she lifts the leg. Now there is no friction. Again she puts the leg at a new point. Again friction acts, but the friction won't move. Friction won't move. Displacement of the friction is 0. That means the work done by friction is 0. Friction didn't move. That is what the important thing is. And many people in advance will probably make a mistake. This can come like a matrix type. Multiple matrix type, where one answer can match with many, or many can match with one, or 1 to 1, whatever. And positive, negative, 0 will be there on one side. Work done by different things will be there on one side. So it's only because the displacement is 0. That's why, not the displacement of the body, the displacement of the force is 0. Okay. Having said this, you will start thinking, sir, then how did Pandu move, sir? How did Pandu get the energy, sir? How did, Champa pull him? Because if negative work was done on Pandu, somebody might have done some positive work. What is the jhol? What is the magic? What is the trick? What is the hidden concept? The hidden concept is that friction did not supply energy to Champa. It was Champa food. Champa ate some food. There is some combustion happening, digestion happening, metabolism. Her cells are active. that internal muscular energy got converted into work against Pandu. That is the answer. Everybody clear about this? Yes, the animator, the friction on Champa is static. This friction, yes, it is definitely static in nature. This is definitely static in nature. Very true. All right. Yes, this is for both Uday Good, for both JEE and NEET students. Concepts. See, friction won't change the value. Friction won't change the direction in JEE and NEET. Friction won't say, oh, in NEET, you know what? I'm going to act against relative motion. In JEE, I'm going to act in the direction of the relative motion. That's not true. It's the same thing, bacha. Concepts are very important. That's what I'm trying to do. Everybody clear? I hope Kushi, Jwala, Animestra, Akash, Uday, N7, Shiv, Ankita, Yunus, Jwala, Ankita, Ramu, Madhusudan, Esaki. All right, everybody. Okay. So think of it this way. Think of it this way. Now, a lot of people, you know, the moment I say this, they also think static friction cannot do work. That is also wrong. That is also wrong. Observe this. Imagine there is a block and maybe there is another block which is being pulled like this, which is being pulled like this, which is being pulled like this. Both the blocks move together. The blocks move together. The blocks move together. If I draw the free body diagram of M1 mass, if I just draw the free body diagram of, let's say, only M1 mass, what will I see? I will see that it is in motion. It is in motion, all right? Both of them are moving like this. They are moving. How will M1 move? M1 will move only because of one force, and that is friction. There can be only one force between these two bodies. That has to be friction. Yes, normal and weight will act, but normal and the weight will only act in the perpendicular directions of the motion. Friction will act. Can you think and tell me which kind of friction will it be? Can you think and tell me which kind of friction will it be? Will it be static or kinetic? Will it be static or kinetic? Sugash, watch this class, then you will understand how to solve problems. There is nothing like tips. Tips and strategy sessions are different. This is problem solving session, bacha. Yes, friction is good and it is evil at different times. True, Kalyan. So this friction has to be static in nature. Why is it static? Because they move together. Is there relative motion? Is there any kind of relative motion? Definitely not. If there is no relative motion, how can there be kinetic friction? So that friction has to be static. Now think and tell me, is this work done by the static friction positive or negative? Is the work done by that static friction positive or negative? Static friction positive or negative? Friction itself moved. As the blocks move, the friction moves. So it will be the frictional force into the displacement, which is definitely positive number. Which is definitely positive number. So when you walk, the friction is static, but it does zero work. Reason being, when you put your foot, if this is your foot, okay, this is your foot, the frictional force is there only. Friction is there. This point's displacement is zero. The displacement S is zero because your foot will be there. You will move. The foot doesn't move. The friction doesn't move. Hence, the work done by this friction is zero only because the force doesn't move. Only when force moves is there work done. Understand this. Is that clear, guys? That's why the previous question, Champa did not do any work because her foot did not move. The friction stayed there as it is. Now, if this much is clear, we can also talk about what does work do on a system. What does work do on a system? And basically it changes the kinetic energy. Everybody knows there are two forms of energy. One is kinetic, one is potential. Their sum is in fact called as the mechanical energy. So let me first talk about mechanical energy. Mechanical energy E, all right, is nothing but the sum of potential energy plus kinetic energy. This U is your potential energy, and this K is nothing but your kinetic energy. The formula for kinetic energy is simply put half mv square. You can also write momentum square by 2m. Both are the same thing. Both are the same thing. For potential energy depends on which system you're talking about. Like for example, the potential energy of a spring which is being stretched is just given by half kx square. Similarly, potential energy of a block is just, or a mass when under gravity, is given by mgh. But this is when you are very, very close basically for uniform gravity. That means the height is much smaller than the radius of the planet. If height is more, then you are going to use basically minus g m1 m2 by r square and all those things, so that you will learn it in gravity. For now you don't worry about it. So this is when the height difference is small, gravity is not changing with height, only then you will use it. So these are some important formulas for kinetic and potential energy. Now, like I was talking about, what does work do? Work changes the kinetic energy of the system. What is this principle called? Changes the kinetic energy of the system. This is called as the work kinetic energy theorem. This is called as the work kinetic energy theorem. It basically says if you add the work done by one force, second force, so on and so forth, work done by all the n forces, okay, this includes internal as well as external forces both. That is nothing but final minus initial kinetic energy. So this is often referred as the work done by literally everything is the change in the kinetic energy of that particular system. This is what it is. This is your work kinetic energy theorem. Now let me show you the application of few of these things so that you understand the concepts and the hidden meaning behind them. Okay, get ready for a question on work kinetic energy theorem. I'm just going to show you how to solve the problems, how to understand the theorem, what is the meaning of the theorem. All of these things you are going to get know now. Imagine guys that there is an inclined plane, there is a block which is kept on it of certain mass m, and the inclination is basically theta, but this inclined wedge is in fact a part of a lift which happens to go up with some velocity v, and this block is basically at rest in the moving, this is moving at constant velocity elevator. Now in the time interval, t is equal to 0 to t is equal to capital T, we need to figure out work done by all the forces, be it gravity, be it friction, be it normal, be it anything. I want to find the work done by each and every force. Everybody with me on this? Yes, I'm going to come to conservative, non-conservative forces. I'm going to talk about reference, potential energy, everything. Don't worry about it. I'm going to talk about everything in detail. We have talked about work. We'll slowly go to work energy. We'll go to potential energy. We'll go to power also. Don't worry. Everybody with me? Let's start with the free body diagram. What are the different forces? Because the block is moving with the elevator, it's stationary. I think one of the forces has to be the normal force. The other force has to be the weight which is going to act down. Also, I think there will be friction which will act this way. These are the only forces, my dear students. Only these forces are acting. And because this is moving up with some velocity in time 0 to t, v constant velocity in time t, how much will be the displacement? Think, v is the constant velocity, meters per second. In time t, it will move v into t. So hence, I can clearly say that this block will move v into t displacement. This v into t is nothing but your displacement. Everybody cool with this? No, there is no pseudo force, Kalyan. Read carefully, constant velocity. there is no pseudo force. If its velocity changed, then I will also put pseudo force. I will also put pseudo force, definitely. Right now, the velocity is constant. If it was having something, I'm definitely going to put that. So let's start one by one. First of all, I think I can calculate the work done by gravity very easily. The work done by gravity, think about it, gravitational force mg, displacement vt, the angle between them, oh my god, the angle between them is 180. Do you see that? It's cos of 180 degrees. Force down, displacement up. That means it is going to be minus mg into vt. So that's the work done by the gravitational force. Great. Now let's go to the work done by the normal force. One by one I'm going to it. So work done by the normal force will be, oh my god, I need the angle between them because work done is force into displacement into angle between displacement and the force. Well, if this is theta, isn't this obvious that this will be theta, this will be also theta. This is also theta, correct? And in fact, even this is also theta. All these angles, I hope you see, are basically theta only. Theta, 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 theta. So the work done by the normal force will be the normal force into the displacement. Displacement is Vt into cos of theta. Great. What is the value of normal? I need to put it over there. Think carefully and answer. What is the value of the normal force? I think normal force is balancing mg cos. Do you see that? Mg cos is actually over here. Mg cos theta is actually over here. And actually mg sin theta is actually over here. So isn't normal balancing mg cos? So shouldn't this be mg cos theta into Vt into cos theta? So what is the final answer? mg Vt cos square theta. That's the work done by the normal. Everybody with me? Great. Now, next thing that you need to do, next thing guys, very good Jwada, very good Kushi. Yes Ankita, awesome. Vt, I hope Nandini, it is understood because displacement is velocity into time, right? That's how you get it. V into t, velocity, speed into time gives you the displacement. That's how I wrote it, V into t. Alright, everybody fine? Cool? Okay, now there is one more force remaining and that is nothing but friction. The work done by friction. Okay, frictions, which component will do work? Don't say cos theta. Don't say cos theta. Friction sin theta. Don't say, sir, but I thought it is only cos theta. Arey haan, but it is the angle between friction and displacement. That angle is 90 minus theta. So you can write cos 90 minus theta or you can write sin theta. One and the same thing. So it will be friction. Frictions, which component? Sin theta component into the displacement, which is V into T. Is that clear why it is sin theta? Everybody with me? Very good. Force in the direction of displacement. But wait a minute, I can't leave the answer in terms of friction. I have to solve it. How? Observe. Now, frictional force, don't you see it is balancing mg sin theta? So shouldn't I write friction as mg sin theta into this sin theta into Vt? That means it is mg Vt sin square theta. Whoa! So I got the work done by the friction also. Mg Vt sin square theta. Okay. Now I have some interesting thing to show you. What if I add gravity, normal and friction's work? The work done by gravity plus the work done by normal plus the work done by friction. What do you think it's going to be? So I can see there is minus mgvt over here, minus mgvt, or I can just put plus mgvt over here. The first term is minus 1. The second term is nothing but cos square theta. The third term is nothing but sin square theta. The beauty of this is cos square plus sin square is 1. 1 minus 1 is nothing but 0. So hence the answer is 0. Whoa. Now you will start thinking, sir, how is it possible, sir? Why is the total work done 0? Is it making sense? I think it is. How? Observe. I just told you the work kinetic energy theorem is total work done is always the change in the kinetic energy. Did I not mention in the question it is moving with constant velocity? If it is moving with constant velocity, is the speed changing? Is the kinetic energy changing? Obviously not. If kinetic energy doesn't change, how can the total work done be anything else? It has to be 0. So this is 0 only because, the change in the kinetic energy is 0. Even if you go it like this way or look at it logically, either ways the answer is 0. This is just telling you how work kinetic energy theorem works. I am not saying you have to do all these steps to find this. This was obviously 0. But I am just showing it to you. See, it will come to be 0. It will come out to be 0 even if you calculate it. It's not going to disobey this particular principle. Is that clear? Beautiful question on work kinetic energy theorem. Now, I think, Kalyan also asked some doubt. Sir, what about pseudo force? In fact, what will happen if there is an additional pseudo force? What if the velocity is not constant? What if, for example, let me make it a little bit simpler over here. Okay. This is, or let me just keep it as it is. It's okay. What if I have that block, but this velocity is not constant because there is some kind of an acceleration? Now do you think the total work done will be 0? I don't think so, because velocity is definitely going to increase. Here it might have less velocity. Here the velocity might become more. Here the velocity might become even more. So velocity is changing. Here if you notice, apart from your regular mg force, normal force, frictional force, there will be additional pseudo force also. Mg is there, friction is there, normal is there. Quickly think and tell me. I know that normal is going to do positive work. Friction is also going to do positive work. Quickly think and tell me, will pseudo force do positive work or negative work or 0 work? Quickly think on, tell me. Ronak, I'm very good. Yes, can we use mg plus a? Yes, you can do that. But otherwise also, I just want you to see, can pseudo force do some kind of work? Okay, directly can you think and tell me? Yes, the displacement is on the top, the pseudo force is below. So yes, it's going to do negative work. Mg is also going to do negative work. If somebody asks you to add all of them, so the work done by normal plus the work done by friction plus work done by weight plus the work done by the pseudo force, will the answer be positive, negative or 0? Will the answer be positive, negative or 0? Come on guys. Sugni is saying negative, Uday is saying positive. Come on. For this one, the total work done, will this sum come out to be positive, negative? Just use your work kinetic energy theorem. Just use your logic. Think and clearly tell me. Very, very important guys. See, there is no point solving complex question if you can't answer this question. These are the concepts. You ask, no, sir, I make silly mistakes. Sir, I don't know what to do. I get stuck. The reason is you don't know what are the simple problems. Solve these questions first. Come on, think. Many people are making so many mistakes over here only. This is such a critical question, guys. A lot of you are thinking the positives and negatives will cancel. That's not correct. That's not correct. The answer is going to turn out to be positive. Reason is the change in the kinetic energy. The kinetic energy is increasing because the speed is increasing. The speed is increasing. Here, speed is increasing. Kinetic energy will increase. So change is positive. So by work kinetic energy theorem, it has to be positive. Got it? No, that it's not negative, it is positive. Such a brilliant question, and so many people make many mistakes. But that's okay. That's the reason why you have come over here. Got it? It's not going to cancel out. Only because of this acceleration. Okay, now you have to think the other way. What if the acceleration was downwards? What if the acceleration was downwards? And what if the velocity was increasing like this? What if the velocity was increasing like this? Then what will happen? I think all these answers might change probably. Maybe. I don't know. You think and tell. What if the acceleration was downwards and slowly it is increasing its speed? Yeah, but it is not leaving contact. It's not accelerating very fast. This acceleration is less than g, okay? Or definitely it's less than g. I think normal will do negative work. Friction will do also negative work. Gravity will do positive work. Pseudo force will also do positive work. The total addition of them the total addition of them. Let's see how many of you can get this. Guys, if you get this, pakka IIT seat. Pakka IIT seat if you get this question right. The total addition of normal, friction, mg, pseudo. If I add all of them, will the answer be positive or negative? Will the answer be positive or negative? The total sum I am asking. It's accelerating down. The speed is increasing. The speed is increasing. Speed is increasing. Kinetic energy is increasing. Change in kinetic energy will be positive. By work kinetic energy theorem, the total work done should also be positive. A lot of you got the wrong answer. Some of you got it. Very good, Omkar. Very good, Jwada. Very good. It is not negative, it is positive. Got it? So this is how trick questions are. This is how your concepts are not strong. This is how you miss so many concepts. You're just probably seen one shots. Yes, it's going to be positive. Very good, Kanan. Yes, Alvin. Yes, Kalyan. It's going to be positive. Understood? Clear? Let's move ahead. Now you will be like, sir, can it be never negative? Yes, it can be negative if as it is going up or maybe as it is going down, the speed is decreasing. How? Maybe it was already moving against, so it is decelerating. If it was decelerating, then the answer will be negative. MS Dawood, to get the fundamental questions of all the chapters, you have to attend my problem solving micro courses. I have conducted problem solving micro courses, HC Verma short answer micro courses, Erodo problem course, micro courses, where I go in detail, one problem I teach for 15-20 minutes. This is exactly how I teach. In fact, better only I will say. Okay? So it depends, problem to problem. I have spent, these are my collection problems where I take a lot of time. Now, another type of question, which is very, very crucial, okay, is let's say there is some kind of activity which is happening, something which is happening, and then you have to find after what time will it, what distance will it stop, or after this distance, what's its velocity. So some situational based question. Some mass is left, it's hanging, it goes and hits something, or some spring is compressed and you leave it, it goes up. So many kinds of questions can come. Let's see one of those kinds also. Just imagine this, okay, where, so what you have is, let's say, a particular, okay, you have this kind of a track, there is this mass over here, M, and what happens is, over here, okay, there is a spring, okay, and this mass, all right, has to reach till this point. Actually, this mass was, let's say, this is like hot wheels, okay, this mass was over here. It has to somehow reach over here, because only then it can reach on the other side. Now this height from the base is given to be h. This height from the base, okay, is given to be h. Now the question is, find the minimum compression of the spring to make the mass go on other side. To make the mass go on the other side. Let's try to solve this question. Observe this carefully. We are just going to use work kinetic energy theorem. That's all. So using work kinetic energy theorem, work done by every force, all the forces, internal, external, will give you the change in kinetic energy. So now identify the forces which are doing work. Think carefully. Zozo, it's not about Menti Bacha. Now you have to grow up, Bacha. You're no longer in 9th and 10th. Menti is good till 9th and 10th, not beyond that. Okay. So now you have to focus on subjective kind of questions, not just objective and just weak quizzes. For that, you have special sessions in your wave, or sometimes we'll do conduct. But today I feel there is a need for solving these kind of questions. Yes, can we use equations of motion also? Yes, you can use, especially when acceleration is constant. Okay, come on guys, think about it. So what kind of forces? Thank you. Oh my God. Indomitable family. Thank you so much. No problem. I'm so glad for all the love from Manipur. So what are the different kinds of forces? I feel there is one normal force. Can you see that? Yep, there is definitely one normal force over here as this block moves. So if you draw the free body diagram of the block, no matter where it is, always the normal force will be like this. The weight will be like this, and the spring force will act for some time. The displacement will be like this. Displacement will be like this. For some moment, there will be spring force also. Spring force also, and this is your weight. Now, do you think, okay, let me just write it down over here first. Work done by normal plus work done by spring plus work done by gravity is equal to final minus initial kinetic energy. Situational based question. Do you think normal force will do work? I don't think so. Why? Normal is perpendicular to displacement. So gone, out of question, zero work. Okay, next. Spring, will it do work? I think so it will, because when you compress it and leave it, spring is going to push it this way. Spring is going to push it this way. Yes? Very good. Yes, Kalyan, very good. Ankita, very good. Thank you for all the love from Andhra Bacha. So, spring is going to do positive work. How much work will it do? It will do half into k into x square. Half into k into x square. Correct? Everybody with me? Awesome. Why is it doing positive? Because force and displacement same direction. Next, gravity. Well, when it goes from here to here, gravity is continuously changing the angle. Gravity is continuously changing the angle. So, am I going to sit and integrate? I don't think so. Gravity is a special force. What is the speciality of gravity? The speciality of gravity, then your electrostatic, and then even spring, all these forces, is that these forces come under the category of conservative forces. Conservative forces. Whereas there are some other forces which are called as non-conservative forces. Forces like friction, normal, tension, viscous. You will learn about viscous forces in fluid mechanics. The fluidic resistance is called as the viscous force. All these are non-conservative forces. The concept of conservative is that if you go from one point A to this point B, whether via this path or path 2 or via this path, doesn't really matter whether you go by this path or this path, work done by path 1 is equal to work done by path 2 is equal to work done by path 3. It's independent. Not just that, if you go via any path and come back, basically it's like a loop, then the total work done is 0 if you go back and come back to the same point. Whereas in non-conservative forces, it's not the same. If you go from point A to point B, maybe you will see the work done is different. Work done in one may not be equal to work done in path 2. So, not just this, if you go and come back to the same point, in case of a non-conservative force, the work done will not be 0. If you go and come back to the same point. Now, this property of these good forces like gravity, electrostatic, spring helps us solve the problems very easily. So, because of which, I can choose a convenient path, and the convenient path can be just this. It goes like this, okay, it just goes like this maybe, and it just goes up. Now, in this path and in this path, both these paths, the gravity will do same work. Gravity will do same work as in this path or in this path. So in this particular path, obviously gravity is perpendicular, there is no work. Only in this direction, when you're going against the gravity is going to do negative work, and that will be minus mgh. Here to here, gravity is perpendicular to the displacement, 0 work. When it is going like this, gravity down, displacement up, that's it. Negative work against. So minus mgh, and it has to just go on the other side. So if you compress the spring and leave it, it's going to acquire some velocity. As it goes up, it loses the velocity, and just when it reaches on the top, even if it has 0.0001 velocity, that is okay. Even if it has 0.001 velocity, that is okay. That means even negligible velocity can be there finally over here. This is hardly negligible velocity, zero velocity. Initially, when you compressed it and left it, just when you leave it, it's going to accelerate because of the spring, and then it is going to move ahead. So initially, it was not having any velocity. So it's 0 minus 0. 0 minus 0. Yes, Pradeep Bacha, I will do it, but right now you have one shots 0 to hero and 0 to superhero of current electricity. You will find it, Bacha. Okay, just watch that 0 to hero or 0 to superhero series is there. There is a one shot on current electricity. So just move this around. So this will be nothing but you are kx square by 2 is equal to mgh. Now you can solve this. So x square is equal to 2mgh divided by k. So x is nothing but root of 2mgh by k. That's your final answer. I hope this is clear. Okay, so this is how you apply work kinetic energy theorem for solving the problems. Now that we have spoken about what is work, what is kinetic energy, how they are related, I think it's good time we also focus on potential energy. Okay, this is very, very crucial, very, very important. Oops, I need some slide. Just 1 second. Let me just add the slides over here. Okay, let me just add the slide. Okay, great. Let's talk exclusively about potential energy now. Now remember, very important line about potential energy. Potential energy is basically the ability to perform work, and it completely depends on your configuration, and potential energy as such has no particular significance, but it is the change in potential energy which has significance. You can be different. That means it is basically not significant. It's not significant. But delta U is going to be the same, and this is what is significant for solving questions. What do I mean by that? Imagine if I take this mass and if I go over here, somebody might say, hey, here the potential energy was 0, here the potential energy is 30 joules. Okay, some other guy will come and say, hey, no, wait, U is actually 10. Here the potential energy is 40 joules. Fair enough. Somebody will be like, no, wait, U is 0 here and U is minus 30 over here. No problem. Somebody else will come and say U is minus 15 over here and U is plus 15 over here. All of them are correct. All of them are correct. Nobody is wrong. What is same in all of them? What is same in all of them is the change in the potential energy. But what is different is what they have assumed to be 0. Somebody is saying this is 0, somebody is saying this is 0, somebody else is saying somewhere in between is 0. Everybody can choose their own reference, but the change in the potential energy that they measure is going to be the same. So generally you always have a 0 reference point. Usually in case of a spring, you usually take the natural length. When it is at natural length, you will take the potential energy as 0, usually. Similarly, in case of gravity, usually it so happens that you take the ground level or some level as 0 potential energy, and based on that, if you take this mass up by height h, the potential energy at that place is mgh, and if you take it down, then you say the potential energy is minus mgh if this height is h. So it's the change which matters, not the absolute value of the potential energy. I hope this is clear. Now, there is a beautiful relationship between potential energy and the force. This is what I want you to understand very, very properly. Observe carefully. Observe carefully. See guys, I just told you the total energy is the sum of kinetic and potential energy. Kinetic and potential, their sum is called as the total energy. Now, if I measure the change in the mechanical energy, I'll have to see how much the kinetic energy has changed and how much the potential energy has changed. If kinetic energy changes by 2 joules, potential energy changes by 3 joules, 2 plus 3, which is 5, will be the joules of energy which has changed in the mechanical energy. Now, just giving you some examples. If imagine kinetic energy increases by 2 joules, potential energy changes by minus 2 joules. Example. Or kinetic energy decreases by 3 joules, potential energy increases by 3 joules. Or maybe kinetic energy increases by 7.7 joules, this changes by minus 7.7 joules. In all these 3 cases, the change in the mechanical energy is 0. This particular condition is going to happen when the total mechanical energy is conserved. If kinetic energy increases, potential energy decreases. If kinetic energy decreases, potential energy increases by the exact same amount. This happens when you are saying basically under the principle of conservation of your mechanical energy. This is the principle of conservation of mechanical energy. When will that happen? I will tell you. Hold on for now. Imagine another situation where let's say this changes by 2 joules. This decreases by minus 1. Oh, there is a problem. This increased by 2, this decreased by 1. So here there is a change of 1. Great. What if this decreased by maybe 5 and this also decreased by 1 or maybe 2? Who knows? Minus 5 minus 2, this is minus 7. Or maybe this increased by 2 and this increased by 3. 2 plus 3, 5. Whoa. Look at this. This is not 0. This is the case when mechanical energy is not conserved. Very, very important. Now, when is it conserved? When is it not conserved? When is it conserved? When is it not conserved? That's also very important. Mechanical energy is conserved when evil forces are absent. Like you do some kind of puja or you do some kind of a ritual because you want to take away all the negative energy. Those evil forces are none other than friction, normal, tension, viscous. These people are not at play. These people are not at play. They might be there, but they are not doing any work. They might be present, but they are not doing any work. Then you can say mechanical energy is conserved. So this will happen when non-conservative forces don't work at all. They don't perform any work. Example, just this problem. Where did it go? This problem. Take the example of this problem. Yeah, they are dormant, correct. It's like virus is there in your body, but it is not doing anything. It's just chilling out. It's just chilling out. Okay, it's just there. Nothing it is doing. MS Dawood, you can join my micro courses by joining the vPro subscription. If you're a part of vPro, you get access to all my micro courses. You join any subscription, doesn't matter. Okay, be it for 11th, be it for 12th. Is normal evil or good? Normal is non-conservative, evil. Spring, good force. Gravity, good force. 2 good forces, 1 evil force. Now you might be thinking, sir, evil force is there. But look over here. Is the work done by non-conservative evil force 0? Yes, it is. It's not performing work. So hence, I can say mechanical energy is conserved. I can also say mechanical energy is conserved. Yes or no, guys? Can I not say that? Just looking at this, definitely mechanical energy is definitely conserved. Now you can make your own story. You don't have to do this. I am going to show you second method for solving the same question. This method was work kinetic energy theorem. Now what I am going to show is using energy conservation. Just because mechanical energy is conserved, make your own story. What is happening? Oh, the block was compressed against the spring. It was left, zoop, it accelerates, it goes up, loses its velocity and goes on the top. So what energy was involved? Like you all have studied back in 7th, 8th, 9th grade. Oh, in a solar cooker, the solar energy gets converted into heat energy and it heats up the molecules of your food. So think same way, which energy got converted into which energy in this entire process? Which energy got converted into which energy in this particular process? Just think about it. I feel the spring had stored that energy and it accelerated. That means the potential energy of the spring got converted into, yes, kinetic energy, but that kinetic energy again went into the gravitational potential energy. Spring gave energy into kinetic, it pushed it. The kinetic energy slowly was lost and it went into potential energy. So can I not say directly half kx square is equal to mgh? Isn't this and this the same? What does this tell you? Whether you go via work energy theorem or simply energy conservation, if it is conserved of course, then you can get the same answer. But yes, usually this method is easier, quicker, faster as compared to this one. Okay, he's very good, Vijay. He has a lot of experience, Mohit Gupta sir, and he has produced a lot of ranks even in the past years and even the last year. He's a very good teacher. I know him personally. Go with it. Don't worry. Yes, Bacha, you can definitely crack Sumant. If you want to aim for IIT Kanpur, you need to put in all the hard work. Please watch all the classes, solve all the books, follow my JEE 2024 strategy, which I have already given. I have given all the strategies for 24-23. Yep. Both are good, Aditya. Both have different aims. Alpha is, the students who have already got some good ranks, and normal batches, it has all the kinds of students. It works both ways. It's not like if you are not in a topper batch or not in a selective batch, then you will not do well. Understand why coaching institutes divide the students based on the merit, because if you enter into a batch which has only selected students based on the marks purely on merit, then you will feel demotivated and you will not work. Similarly, if there is a good student who enters a batch where very slow teaching is happening or not very good level of questions are happening, then the student will lose interest or he will not feel good. So that's why the division happens, and when you do well, you will automatically enter into the Ekalavya or the toppers batch. Don't worry. Okay? Great. Chalo. Now, having said about potential energy, there is one more thing which you need to know. Potential energy and the work is always related, and you will always see that whenever we talk about potential energy, it's usually for potential energy is only defined for conservative forces. Conservative forces only. Look at the names of the potential energy: gravity, spring, electrostatic. These are all conservative forces. You never will hear the word frictional energy. So, what's the relation? Here is the relation, guys. Just look at this. If you have some kind of a system and there are some bodies in it, and there is some kind of force which happens to be conservative, this is your conservative. Obviously, non-conservative system, you cannot define potential energy. This force will do work. This force will do work. And whatever work is done by the conservative force is the negative change of the potential energy. Very crucial result. Very crucial result. Why is that negative sign there? You should understand. Observe carefully. Imagine in a situation where the potential energy increases. Imagine in a situation where potential energy increases. That means delta U will be positive, so it will be negative of that positive number. If potential energy increases, the delta U will be positive, minus of positive is negative. So the work done will also be negative. What does this mean? Simple, guys. If conservative force is doing negative work, that means it's sucking away the energy. From where? The kinetic. It takes in the energy, it sucks the energy and stores it in potential. So the work is negative, that means it sucks that energy, maybe the kinetic energy, and stores it as potential energy. That's why that minus sign is there. Very good concept. If you still don't understand, no problem. I'll tell you a beautiful example. You throw a ball up. You throw something up. What is happening? Gravity is acting down. When it is going up, gravity is acting down. Displacement is on the top. What is the work done by the conservative gravity force? It's negative. Gravity is sucking that energy. This ball, this pen, the velocity is slowly reducing. When the kinetic energy reduces, where is it getting converted? It's obviously getting stored as the potential energy. I hope this is clear. So Aditya, if you are if you can't understand fast, then you should go to the normal batch, or you should slowly increase your speed. That's what you should do. Yeah. So try to be in a normal batch. It's okay. Don't worry. Is that clear, my dear students? Everybody with me on this? Great. Now from this only you get many additional results, like if there is small work done, so for small work you get this formula. dW is equal to minus du. Work is nothing but F into dx is equal to minus du. So from this only you get F is equal to minus du by dx. So conservative force is the negative of the rate of change of the potential energy with respect to your displacement. This is where that formula comes from. Aditya, I'm taking the AI Live batch, so that's the paid batch for droppers. Yes, so you have that option. It's slow only. Cool? Beautiful. So maybe I think it's time now to solve some questions, and remember all these notes, all this revision, these concepts, whatever I have revised for all of you is there in the Telegram channel as a PDF. I will upload it maybe by tomorrow. So here is the first question coming up on your screen. Let's do this. Okay, so there is rapid fire now. I want you to solve all these questions. A position dependent force is acting on a particle and the force position curve is shown. Work done on the particle when the displacement is from 0 to 5 meters is how much? Remember, work is nothing but the area under force versus displacement graph. So maybe I should just calculate the area under the graph, but I can, how do I do that? I can use the formula area of a trapezium. Area of a trapezium is half into the height into the sum of the parallel sides. This is the formula. Just use it, you will get the answer. Like over here, this side is just 1. This side is nothing but 3. This height is nothing but 10. So the area over here is half into height, which is nothing but 10. Parallel sides is nothing but 1 plus 3. So 10 by 2, 5. 5 into 4 is nothing but 20. So this is 20, this area. Similarly, you can also calculate this area, this area. So over here, this is 10, this is nothing but 2, this is nothing but 1. So this area will be half into height into sum of parallel sides, so 1 plus 2, but this will be negative because it is below. So it will be minus 10 by 2, 5, 5 into 3, 15, so minus 15. So therefore, the total work done will be nothing but the positive work, which is 20, and the negative work, which is 15, but negative because it's below. Hence the answer will be just 5. That is the answer. Yes, Best Boy channel. Very good, Ankita. Awesome. Option D is correct. Thank you, Kiara, so much. Is that clear, guys? This is how you're going to solve the question. You can add the triangles. I've seen many students do this, especially JEE students. If you guys are adding the area of triangles and the rectangle, please don't study engineering. I mean, you should really know the area of a trapezium. You cannot be at this stage and add the areas of the triangles. That is going to just slow the process. How do you expect to solve objective questions in a time-bound exam like JEE, where you have to solve almost one question in every 2 minutes? You have to find and catch up speed at every possible moment. Okay, moving on to the next question coming up on your screen. Here it is. For the path, I think P, Q, R, P, I think that I think this Q has come extra, PQR. In a conservative force, not conservation, conservative force, the amount of work done in carrying the body from P to Q and Q to R are 5 and 2. What is the work done in carrying the body from P to R? Is it important for NEET students? Yes, so they're good. If you want to score really quick, what do you need to do? How do you increase the speed? Calculations, table should be known. So you have to have an edge over other students. What will other NEET students do? They will by heart, area of triangle, area of rectangle, area of this. No, you are not going to do that. You're going to use the trapezium area. That's why you're studying under me, no? Or else if you have to use the same thing, then you will be at the same average speed of all the other NEET students. Okay. Hello Kumar, welcome bacha. And option B is it? Let's try to figure it out. Okay, so from P to Q, it is 5. P to Q is basically 5. From Q to R, it is 2. Q to R, it is 2. Question is, what is the work done from P to R? From P to R. Oh, wait a minute. I go from this point to this point, this way or that way, it's going to be the same, it's conservative. Work done is independent of the paths. So work done will be 5 plus 2 irrespective of how you go. So that's going to be 7, which is option A, of course. A lot of you are saying 3, I'm not sure how. Guys, be careful, it's not 5 minus 2, it's 5 plus 2. 5 joules, 2 joules, 7 joules. It's not 5 minus 2. Why is it 5 minus 2? I'm not sure. Thank you, Bacha, for all the love from Tamil Nadu. Thank you so much, Bacha. Kushi, if you want to improve your calculation speed, try mental math. Try to learn all the tables till 30, squares, square roots till at least 10, 20. And also, whenever you see any addition, subtraction, multiplication of 2, 3 digits numbers, try to do it as much as possible mentally. That's all. Thank you, Maji Satyavati. Thank you so much. Very good, Best Boy channel. You got it correct. Okay, these are all conceptual questions. I know many students make mistakes. Okay, what about this? When this position is changing with time, I think it's a variable based question. And the question is, what is the work done by the force in the first 2 seconds? Please do not use work is force into displacement. That won't work. Reason, force is not constant. Then you'll be like, okay sir, I know what to do. Work is integral force into displacement. How do you know the force? You do not know it yet. What do you do now? There is only one way now, and that way is using work kinetic energy theorem. This will help you. The work done will be final kinetic energy minus initial kinetic energy. Basically, it will be half into m into v square minus u square. I'll be like, sir, I don't even know the velocity. What are you talking about? Okay, we need to find something. You can't say, sir, I don't know this, I don't know that. You have to find something. Since position is given, I think you can find velocity. X is t cube by 3. V is dx by dt. So it will be derivative of t cube. Oops. One sec. It will be derivative of t cube by 3, which will be 3t square by 3, which is just t square. That's the velocity. So substitute the values now. Substitute the values. So first thing, mass is 2. Put it over here. V, acha, it's t square. I think first 2 seconds. So t square. Very, very crucial. Many people miss that square. Remember, why am I putting 2 square? If you're not able to follow it, no issues. I'll write it over here for you. Velocity at t is equal to 0 will be 0 square, which is 0. Velocity at 2 seconds will be 2 square, which is 4 meters per second. So I'm going to put 4 over here, square it, and then 0 over here and square it. So now it's simple, guys. 2 cancels, and just have 16 joules over there. That's the answer. I hope that's clear. Yes, that's done. Done. Need you to take section in Tamil. Kumar, I wish I knew Tamil, bacha, but I'm pretty sure many students from Tamil Nadu do understand English, and I can see all the South, generally the South Indian states are very well versed with English. So please like to learn in English if you can. Otherwise, if I knew Tamil, I would have definitely conducted lectures in your regional language also. What is meant by relative motion? Relative motion is basically, the motion occurring when you sit on an observer or a frame of reference and you see the other body moving with respect to you. It's a perceived notion. Like when you sit in one train and look at the other train, it moves relative to you. It's a perceived motion. Okay, that's what is relative motion. All right, chalo. Cool. Let's move on to the next question. The potential energy of a system increases. The work done is. Beautiful conceptual question. Thank you, Uday. Hi, Sai Rajshekhar Reddy. Welcome, bacha. Come on. Can I enroll only for micro courses? Basically, I'm JEE 2023 dropper, please. No, Dawood, it's not possible, bacha. If you want, enroll in the cheapest and the simplest of the pro subscription. I think it will be around 10 to 14,000 for the droppers. Or even for 12th standard, you can enroll. 12th standard has 11th standard micro courses also. So that is also an option. I think it will be around 4 to 5,000 rupees. Just check it out. Okay. So what do you think the answer will be? Potential energy of a system increases. That means delta U is positive. Right now, I just told you, delta U is negative of the work done. So if this delta U is positive, that means this work done should be negative, because minus into minus is plus. If the work done, oh, by the way, this is only by the conservative force. If the work done by the conservative force is negative, conservative force is not doing work. Work is done on the force, or it is done against the force. As the work done by the conservative force is negative. If it is done by the conservative force, then the work done by the conservative force will be positive. Since it's negative, I'm just going to stick with option A, I guess. Yes, it is correct. Is that clear? Everybody with me? Very good, Jwada, very good, Subhagya. And some of you, yes, some of you wrote B. No, it's not B, it's option A. This minus sign plays a very crucial role over there. Moving on to another big question out here for all of you. Here, the energy is not conserved. Look at it, it loses its energy. The kinetic energy and potential energy, the sum is not constant. Question is, what do you think is the velocity at point B? Beautiful. Now, here is my simple logic. Usually, when energy is conserved, kinetic plus potential is kinetic plus potential no matter when you measure it. But when it's lost, here is what I feel might happen. Initially, there might be some energy. Finally, that energy might be less. This is the total mechanical energy. This is that total mechanical energy. And maybe there is some kind of a loss. If there was 100 joules, finally maybe there is 90 joules, 10 joules is lost. Initially there was 50 joules, 20 joules is remaining, 30 joules is lost. So this is how the equation will come out. Cool. Now initial energy will be nothing but initial kinetic plus initial potential. Final energy will be final kinetic plus final potential. Loss as per the given question is 10% of its total energy. 10% of the initial kinetic plus initial potential. This is what the equation will come out to be. Cool. Now carefully start filling these equations up. Here is what I'm going to see. If I take this level as 0 reference, here the potential energy finally is 0. Here the initial potential energy will be mg height, mg into height, which is basically 2, okay, h is 2. Here initially it was just left, so it is 0. Finally when it comes down, it will have half mv square. Aren't these the variables that you're going to use over here? Check this out. Everybody with me? How to resolve the forces best boy channel? Just watch my previous video on Newton's laws, friction and all of that. I have taught beautiful tricks and tips on how to resolve the forces. Division of 8 method and all of that, which basically you will never get confused. And also watch my vector resolution class that also I have conducted only on vector resolution and how to represent vectors. Hi success stories, welcome bacha to the channel. So here I'm just starting to substitute initial kinetic energy 0, initial potential energy mgh, okay, mass I think it's going to get cancelled maybe, finally it's half mv square, final potential energy 0, 10% that is 1/10 or 10 by 100 or 1 by 10, one and the same thing, initial kinetic 0, initial potential energy mg into 2. Great. Now what's going to happen over here is m just gets cancelled, and let's start solving this. G into 2, that's 20 because G value is 10. This will be V square by 2. This will be nothing but 2G, that's 20. 20 by 10, 0, 0 cancels. This will be 2, right? So move this around. So this will be V square by 2 is 20 minus 2, which is 18. So V square will be 2 into 18, which is 36. So V will be 6. That's the answer. Just check this out. Is it there as option A? Yes, it is. Hello Boya Ravi, welcome bacha. All the new warriors, please welcome. Make sure you are hitting the like and the subscribe button so that you do not miss any of my classes. Is that cool, guys? Everybody with me on this? Everybody understood? This is a beautiful question where mechanical energy is not conserved. Look at this, evil force, non-conservative force. That's what I was telling you some time back. Where is it? Our theory. Look at it over here. Yes, mechanical energy is not conserved when there is a non-conservative force which is doing work. If there is a non-conservative force and it does not do work, no problem, then energy is conserved. That's what I had told you. So there will be losses in those cases. Great, let's move on to another question maybe. Coming up on your screen, it's a beautiful question. 100% many people do not know the difference when some language is changed in this question. I change some words, many people will still solve the problem in the exact same way, or they don't know what they are doing. Observe this question. Question is to find the average power for a particle which is undergoing uniform acceleration. Thank you, Kushi, for liking it. Let's solve this question. Question is, what is the average power? So power is force into velocity, right? That's, or work by time. Cool. So force is nothing but mass into acceleration into velocity. Great. Now acceleration, I can say it is nothing but, because it is uniformly accelerating, can I not say acceleration is final velocity minus initial velocity by the time taken into v. So this will become mv square by t. This is the power. This is wrong. This is wrong. Is that option there anywhere? Yes, it is there as option A. This is wrong, guys. I'll be like, What nonsense. What went wrong, sir? I think it is correct only. No. This is wrong. How many of you can identify the mistake in this? Think and let me know. If you can't, no problem. I'll help you. Now let me show you something else. Power is also work divided by time. Work, by definition, is nothing but final kinetic energy minus the initial kinetic energy by work kinetic energy theorem by time. Final kinetic energy is half mv square, initial is 0 upon time. So from this I'll get half mv square by t, exactly half of this answer. Exactly half of this answer. Let me show you, this is the correct answer. Yeah, this is the correct answer. D option. Now I'll be like, what nonsense? And you would never have thought about it. By mistake you would have done this. Imagine, by mistake you did this and you got it and you would have proceeded ahead. You would not have even realized that there is a chance, it's just purely by luck. You might have just done this in the exam and you would have got this and you would have marked option A. Only those students by chance who have marked this would realize that this is wrong. What is the problem? How many of you can tell me? The problem is this word over here. Average power. Average. When I say average, it's the total energy or the total work upon the total time. So this is basically the formula that you use for average. Average. This formula is what you use for instantaneous, at that instant. In fact, it is going to be dw by dt. There is a lot of difference between total work by total time and derivative, instantaneous rate of work. This is instantaneous. This answer is for average. Here the word used is average or the total power. So that's why I'm going to stick with this. If the question did not mention this word, if the question was what is the power at that instant t, then I think this will be the answer. What a brilliant concept. Did you get it, guys? Okay, so dw by dt or f dot v is the force into velocity at that instant, not the average. So be careful. Moving on to another question. This is very simple. You should be able to answer this within probably 10 seconds, not more than that. Come on, I'm waiting for all of you. A body of mass thrown at some speed at an angle of 60 above the horizontal. The power due to gravity at the highest point is. Naveen, attend the Tattva discussion sessions, number 1. Number 2, make sure you have solved the class homework and the assignments first. Number 3, look at the solved examples of Tattva before attempting many problems. Number 5, go with exercise 1, then attend the discussions or watch the solutions, whatever, or see the solutions behind. Then go to exercise 2. Even if you reach till exercise 2, for the time being, till the syllabus is done, that's fine. During revision phase, you can push yourself to 3 and 4. That's perfectly okay. I'm so glad JEE 2024 you are enjoying my recorded classes. That's the ALF version. It's not actually recorded. It's not actually live. It's somewhere in between. Like my lectures are recorded, but the class teachers, quizzes, polls, everything are live over there, right? Okay, so the correct answer is 0 because it's perpendicular, obviously. The gravity is like this, the velocity is like this. So once they are perpendicular, F dot V, this dot product cos 90 is going to be 0. That's it. Hence, the answer is 0. Very good. Moving on to another question. Now, don't get scared by the length of the question. It's very simple. This is a graph of potential energy versus position. And there is a energy graph of a particle basically oscillating back and forth. As the particle goes towards the left, the potential energy increases. As the potential energy comes back, 0. Again, it goes there, it increases. So as the particle goes back and forth, the potential energy graph is given. Here, these two are the extreme limiting values on this side or this side till which the particle can move. It can't come here, it can't go there. It will be somewhere in between this, it is trapped, it is just oscillating. That's what the question is. The question is now, if V and K indicate the potential and kinetic energy respectively, then at this or this point, which of the following options are correct? Come on, think about it. Think carefully and answer this question. Very, very simple, guys. Just concentrate on this point and this point. Think what is happening. What is happening to that block? This is x is equal to minus xm. This is x is equal to plus xm. This is x equals to 0. And it goes there, stops, comes back, stops, goes there, stops. So you see the word stop. It stops over here. It stops over here. That means the kinetic energy must be 0. Kinetic energy must be 0. But obviously there is potential energy over there. In fact, potential energy is the sum of kinetic plus, or I would say, sorry, my bad. I would say the total energy is the sum of kinetic plus potential. Kinetic being 0, E is equal to V. Same thing over here. Total energy is the sum of kinetic plus potential. Kinetic being 0. Therefore, the total energy is the potential energy. So I think option number B is correct. Yep, it is. Very good. Yes. Awesome, guys. Biren, you will get blocked, bacha. Don't unnecessarily spam. This is not a platform for you to flirt. Okay, respect the privacy of other students and respect others, sincerity towards the channel and towards towards JEE. So make sure that you do not get blocked by spamming like this. All right, is that clear, bacha log? Everybody? So the main concept over here was the mechanical energy is conserved. Kinetic energy becomes 0 at these two positions because it stops over there. Okay, this is another beautiful question, guys. Let's try to solve this. Last one or two questions. Last one or two questions. Yes, I'm going to send the slides as PDF in the Telegram channel as well. Okay, so here is what the question says. A raindrop falls from some height. So this is the raindrop. This starts from some height. This is velocity is going to be 0. As it comes down, the velocity slowly increases. And once it reaches a certain height, which is 3h by 4, the terminal velocity is reached. Terminal means final. Like terminus, terminal is the final, eventual. So the velocity no longer changes. Here the velocity is increasing. After this, the velocity is just constant. So that is what it is. And this happens maybe at a height of, I don't know, 3h by 4. At a height of 3h by 4. And this total height was h. Here, kinetic energy is basically increasing. It's increasing. Here, kinetic energy is basically constant because it has reached the terminal speed at this particular point. But if you look at the potential energy, meanwhile, potential energy continuously is decreasing. Potential energy is continuously decreasing. Okay, so if I have to draw the graph, okay, of the change in the kinetic and the potential energy during the fall, here is what I will say. If this is energy in general, I will say that the kinetic energy first increases, then it becomes constant. So first it increases and then it becomes constant. That's it. This is your kinetic energy. Whereas potential energy graph obviously will decrease and it will continuously decrease. Initially it will decrease faster. Okay, maybe maybe like this, and then it will just become constant like this. So it will keep on decreasing like this. It decreases faster initially because it is coming down. No, I'm so sorry, it will not decrease faster. Sorry, this is not the graph, my bad, so sorry guys. Initially the speed is less, so it is coming down at a small speed. So that means the height is decreasing slowly. Eventually the height decreases really quick. So I think it will first be like this and then it will be flat. Potential energy always decreases, but then it will become a constant rate, because once kinetic energy becomes constant, the height will reduce at a constant rate. Potential energy will also decrease at a constant rate. That's how it is. No, kinetic energy is not decreasing, bacha. Look at this. Kinetic energy is remaining constant. This is your potential energy. Do you see? Till this particular point, probably till this particular point, you know, it is increasing. After this, it has reached terminal speed. Is that okay? That's how this question is. Can we move ahead? Can we go to the next question? Have you understand what has happened? Terminal speed is the final speed. So till it reaches that speed, the speed increases. After that, the speed is constant. Kinetic energy is constant over here. Potential energy decreases slowly because the speed is less over here. Height reduces slowly. After a point, the speed is constant. So the potential energy decreases at a constant rate. Okay, one more beautiful question. Okay, now here is the next question. Beautiful question again on friction. Okay, I want you to see this. It's a combination of Newton's laws and work, energy, power. Question is, in the first 2 seconds, if both the blocks are moving or the below block is being pulled, what is the work done by friction on the block? Coefficient is given, mass is given, everything is given. Okay, here is what I think we can do. If you take both of them as a system, it will become 12 kg mass. There is only one force acting on it, and that is 60 Newton. This system will accelerate. So I can say force is equal to mass into acceleration. 60 is equal to 12 into acceleration. So acceleration will be 5 meters per second square. So if they are being pulled together and they move together, they will accelerate with 5 meters per second square. Okay. To find the work by friction, I need to know the friction, na? I need to know how much friction is acting. So let's find the friction. How? Draw the free body diagram. Let's do that. Take this 2 kg block. Take this 2 kg block. Show the forces acting on it. What are the different forces? Well, one is mg, which is 2g. Then you also have the normal. This block is accelerating with how much? 5 meters per second square. Who is going to accelerate it? Why would this block accelerate? Think about it. Think about it. Think about it. Why would this block get accelerated? There's only one reason why this block will get accelerated. That is friction. Normal mg can't. Pseudo, no. We are sitting in the ground and seeing that block go like this. We are just seeing the block go accelerate like this. So friction is pulling it. So friction will act like this. So can I not say friction is nothing but mass into acceleration? That means it is 10 Newton. Great. Now you will be like, okay, now sir, I can find the work done. Friction is there, displacement is there. A lot of students do this silly mistake. They can get it wrong, they can get it correct. It depends, because coefficient of friction is given. My question to you is, how do you know the blocks are moving together? How are you so sure that the blocks are not slipping? Did we check that? No. So then how can you say that they are moving together? So maybe we need to check it. If they move together, then this is the friction, this is the acceleration. But is this friction? Is this friction less than the static friction maximum limit? I don't know. I don't know. We need to check it. Check it out. What is Fs max? What is the maximum limiting frictional? Mu mg. Mu is 0.6. Mass is 2. G is 10. 0.6 into 10. 6 into 2. 12 Newton. Oh, we are safe. This force is less than 12 Newton. That means you have not yet reached the limiting value. And friction is a self-adjusting force, especially the static one. So the actual force, the actual frictional force is this value only, not this. If it was more, if this symbol was more, let's say this was 15 Newton, then it will not accelerate this way. It will have some kinetic friction. That would be a completely different question. Okay, so now it's 10. So the work done will be frictional force into displacement. Frictional force is 10. Wait a minute, now I don't know the displacement. So how do I find the displacement? Displacement is ut plus half into at square. U is 0, acceleration is 5, time 2 seconds, so 2 square, 2 gets cancelled, 2 5s are 10, so 10 meters is the answer, so put 10 over here, that's it. Then you will get the answer as 100 joules. 100 joules, and it's positive, so yep, option B, done. And this will be also into cos 0, guys. Reason is friction and displacement are in the same direction. Is that clear? Sir, 8:45 ko unga class irku sir Vedantu la please. I don't know. I don't know Tamil. How would I know? Okay. Hello Shubham Samal, nice to see you back. J 2024, you're not blocked, bacha, you are seen. Okay. Chalo, let's go to, yeah, oh, that was the last question. And this is your homework question. Please put up the answers in the comment section. I would be eagerly waiting to see all your answers. So, solve this, answer, everything will be put up in the PDF. Where are you going to get the PDF? In the Telegram channel, right? That's a standard place. And also take a moment to congratulate all your seniors, your batchmates maybe, for JEE, achievements. 2,600 plus students clearing JEE mains. Not just that, 2,500 plus students clearing JEE Advanced. 1,100, this is not 1,000, actually 1,100 students clearing NEET exam to get into a good government college or a very good private college. So these are our outstanding results. And this is something which you should always bear in mind. And this puts in that faith for you guys in the system, and also should make you feel very proud about your seniors or your batchmates. And it should also motivate you to work very hard for the next year. With this, let's sign off. Make sure you smash the like and the subscribe button, and put up your answers of the homework question in the comments. Stay tuned for more lectures from my side. Lots and lots of sessions coming for all of you. Usually I come at 7 o'clock. Bye bye till then. Have a great dinner. Hasta la vista. This was Captain Shreyas.